subject to some constant. So that constant will be, for example, g of x. And for example, I'll write it like this. So multivariable variable function we have, for example, f of x and y, and constant function, for example, we have g of x y equals to c. Correct? So it follows two steps where we are able to find the Lagrangian multiplier, value of Lagrangian multiplier, and with the help of that, we'll find out the value of x and y, and we'll see at what level of what is the best possible combination of x and y where we can minimize or maximize the function. So our aim is minimizing or maximizing the function. Okay. So what is the first step? For example, the first step is introduce in this, for example, introduce a new variable lambda. Okay. So the first step is introduce lambda and then define a new function and define new function. For example, L, or you can give it any name, that's not matter. And we can write it, for example, like this: lambda x y lambda. We write it like this equals to, or it can be not, it can be many variables together, x, y, z, so many plus lambda. Then what, how we write? We write here the function, we write f of x and y minus, then we include the lambda function. Lambda function g of x and y minus c. You should know it. How do we do it? Okay, because it is already done. So this is the core function which we have already discussed in the many classes when we are discussing the Lagrangian multiplier. So what is new here? Nothing is new here. It is the repetition. Only thing is you need to remember how to interpret the thing. That is new here. Like in that we were trying to solve the functions. So how do we interpret the Lagrangian multiplier? That's our core topic. So this L, or you can give it any, it is not necessary that L will only represent this function. You can give it third, you can give it any value. So this will be treated as what? It will be called as Lagrangian. L or Z will be called as Lagrangian. And the new variable, you know, new variable, what is the new variable? And the new variable lambda will be referred as Lagrangian multiplier. Correct? Wait 1 minute, I will put some. Right here. Lagrangian multiplier, okay? Correct? Then what is the second step? What is the second step we do? The second step we do is we find the differentiation of it, and we put the differentiation equal to 0. That technically, what is that called? This much is enough. This much is clear. We have already done it. I am using the terminology, little terminology. Second step is set the gradient of L equal to equal to 0. Fine. 0 or 0 vector if it is more than 2. That means, what does that mean? That means this is the symbol of differentiation. Okay, put x, y, and lambda equal to 0. Okay, correct. So what do we? What is our job? Our job is our job is to find the critical. Our job is to find the critical point of this L. So all the three. That's we know we have done it till now. Then what is the setup three? Setup three we follow. Setup three, after getting this solution, which will look like which will take some values. Okay, which will take some values. For example, values will be x0, y0, and lambda 0. Plug these values in the original function f. Okay, or you can get these values and we can substitute this value in each other certificate, so that we will get the maximum. We will get the maximum function or minimum function. Okay, whatever is needed. So what is our job next? We need to substitute these values in the in the three equations. After we get the x1, y1, and lambda. After we get that, and we can substitute these values in the original function to get that absolute number, which will denote as the maximum output or whatever revenue, whatever is that. Then after that, we'll also be able to find the combination of different x and y, which will be best possible combination, either maximum or minimum. Okay, which we have done in the last class, not yesterday class. 2 3 classes back we have done. Okay, so we have done that already. So that's not anything new. Fine. So lambda will treat as a new variable, as an input variable. Okay, and it will give us some interpretation of the function. Okay, for example, what will be the interpretation of that? We will go to this function. We have a problem here. Okay, we have a problem here. Suppose you are running a factory producing some sort of uh, some products that require steel as raw material. That requires steel as raw material. Your costs are predominantly human labor. Okay, which is 20 per dollar, $20 per hour for your work, and the steel itself, which runs for $170 per ton. Suppose your revenue is loosely modeled by the this is the revenue function. Okay, and if your budget is H represents the hours of labor, and S represents tons of steel, which is used in the function. If your budget is $20,000, what is the maximum possible revenue? So what we have to get? It is the revenue function, correct? This is the revenue function. So what we will do? So we will try to make it in the in the form of like what is that called, a revenue function form, and we'll see what can be the possible. We will not solve it fully. I will not solve it fully. I only need to get the value of beta, and with respect to this example, I will try to we'll try to interpret the value of lambda. Yesterday I have given you one definition. So with respect to that definition and with respect to different context, how to interpret the value of this function. Okay. Fine. Wait a minute. We have this function, we have this problem. We want to solve this problem with respect to lambda, with respect to revenue function, and we have to. This is the budget constant in the problem. Okay, our budget is $20,000. For instance, $20,000 only. So we want to maximize our revenue. We want to maximize our revenue with the given budget, and our model is also given here. Okay, so how do we write it? For example, I will write a little here. How do we write it? For example, the constant function and the basic function. Hmm? For example, we will start writing the lambda function like this. It is h, it is s, and it is lambda. It is based on the function which function? Based on the function revenue function. Revenue, where revenue is the function of h and s, right? And we have constant function. Constant function. What is the constant function? You look at here. We have, this is our one thing and this is our another thing. Correct? So we have $20 per hour of the labor, and we have 170 tons of dollars for the steel. Correct? And we have budget 20,000. These are the three inputs or three given things. So how we will make it constant function? We will make it constant function like this. 20h, okay, plus 170s, correct, equals to 20,000. Correct. So this will be our constant function. Constant function, correct? This will be our constant function. Now, how to input this function and how to like write the composite function, basic function. We have here the basic, or what is it called? Objective function is here. This is constant function. I will write in this here. I will write here. I will just erase it. Not already. So what will I do? I will write the constant and this. I will write the composite function. So our basic function. What is our basic function? What is our objective function? Objective function is 200 h2 by 3 into s1 by 3. This is our objective function. Objective function, okay? So it is equal to or the revenue, correct? Is the revenue function, where revenue is the function of h and r. H means hours, like hours of labor, steel in tons. That is what it means. So constant function I have already written. So how do we write the composite function then? Constant. This is this function, and constant function is, for example, it is, I have written already, 20h plus 170 s equals to 20,000. So we will write the composite function like this. Lambda h hours of labor, s steel in tons, and lambda new variable equals to the revenue function or the objective function first, 200 h 2 by 3 s 1 by 3 s1 by 3. Hmm? We have s1 by 3. Then what is the next step? Then we have to do minus, we have to input the lambda value here. Okay, variable which we have already done in mini class. You know it very well how to do it. That's why I'm not going to solve it much. I am only going to interpret the things. Okay. What is the function inside? Inside function will be 20h plus 170s plus, no, not plus, here minus. This will become minus when we make it, when we bring it that side, it will become minus. Minus 20,000. It will become like this. This is our composite function. Then what is our next job? Our next job is to do the differentiation, first differentiation, second differentiation. First differentiation to get the value of x, get the value of first differentiation we do to get the value of h, s, and lambda. Okay. Second differentiation we do sufficient condition. Second differentiation we do to find out which function it is, whether it's a maximum or minimum function. But right now we don't need to do the second differentiation because it is given that we have to maximize the revenue with the given budget. So we have to maximize it. I don't guess we need to do the second differentiation, sufficient condition. Only if we get different values, then only we may need to do the second differentiation. But when the function is given, it is maximum like revenue, we need to maximize the revenue, so we can easily find it out. If we get two values, if we get two values of these, then that time we may need to, if we see the classical optimization, there we need to find. But right now here we don't need to do a sufficient condition. Okay, the sufficient condition is second difference and finding out whether it's a maximum or a minimum. And I have given you the formula also last time. Now, what is the job here? Till now, you know it very well. And after that also, you know it very well how to solve it. I will not solve it as of now. You do it as your homework. Okay? Then what is our third job? Then we find, what is our third job? Then we find the critical value. We find the critical value of pointers of lambda. That means gradient of L, we put H, we put S, we put lambda equal to 0, means first differentiation, we put equal to 0. After that, what we do? After that, what we do? We do one thing, we derive the different values, okay? Because there might be several solutions for this equation. There might be several solutions, okay? So what we get, what we will get, for example, what we will get after putting this equal to 0 and solve, get h naught, s naught, lambda naught, for example, one equation, or we may get h1, s1, and lambda 1, or we may get h2, s2, and lambda 2. In a vectorial form, it will become like this. We make it. So what is the purpose of these values? The purpose of these values, h and s component, is with respect to the revenue function. Then we put different combination of values in the revenue function, and we will actually find which function is maximizing the revenue. Okay, so we will be able to find which one actually corresponds with the maximum revenue. Which function? H naught function, H1 function, H2 function. Okay. For example, we got some values. Hmm? We got some values. We got some solution for this. That solution is S star. We got S star. We got lambda star. Hmm? This star means the derived value or the solved value. Okay. It is the solution, solved value. This means H star and H star and S star represents the hours of labor and tons of steel you should allocate to maximize revenue subject to your budget. Right? H star, this H star and S star represent the hours of labor and tons of steel you should allocate, you should get combined to maximize revenue subject to your budget, $20,000. But then one thing is left, that is okay till here. But how do we define this that time? That's the main point. How do we interpret the Lagrangian multiplier lambda star that comes with these maximized values, H star and H star, because these are the solid values. We got, for example, in the last function when we see the TV sets, 90 TV, for example, we need to produce a total 90 TVs. If you remember, we need to produce the 90 TVs A and B for how many A and how many B forms TV X and Y by A X by B Y TVs. How many how many TVs by X and how many TVs by Y will produce, so that our like production will be maximum and revenue will be maximum. So that time we have found 60 plus 30 something, 60x like this, 60 by X plus 30 by Y equals to 90. That way we have got this. So similarly, we will get some values here. But there is one more component. When we get these two values, X and Y, one more component is there, that is lambda. So how do we define, how do we interpret the lambda? That's the main topic. Like how do we interpret the lambda? Any guess, like if we get any value of lambda, what will lambda tell us? Because this H will tell us hours of, shall I write it? This H will tell us hours of labor, and this S will tell us what it will tell us. Tell us tons of steel. It is steel, tons of steel. Okay. What the combination of these? The combination of these, allocation of these, allocation of these to maximize the revenue function. To maximize the revenue function. Correct. Subject to our budget constant. That is this much. Correct. So till now we have got it very clearly. Then what is will be the interpretation of lambda? The lambda will be interpreted as lambda star in this case will be interpreted as it will tell us how much more money we can take by changing our budget. This is the role of lambda here, and that's all. By graphical representation, I can show you. By different representation, I can show you. But just try to understand the role of lambda. Lambda will tell us how much more money we can make by changing our budget. If we change our budget from one point to another point, what will be the effect on revenue? Right? What will be the effect on revenue? So this is the role of lambda here in this function. Yesterday I told you it's the rate of change. It's the rate of change in x with respect to unit change in lambda. Yesterday I told you in the definition when I wrote you. Here, with respect to budget function, it will tell us how much more money we can make by changing our budget. If we change our budget by, for example, what do I mean by that? If we change our budget from 2,000 to 3,000, 20,000 to $30,000. If we change our budget from 20,000 to $30,000, the lambda will tell us how much revenue we can make more. What will be the total effect on the revenue? This will be interpreted, or this will be reflected by the lambda. Correct? Then how would I write it? For example, how would I write it? For example, I will write it. For example, I have two things now. One is revenue, one is budget. Then this revenues we have to maximize. I will write maximum revenue like this, or revenue function, where this star means the maximum revenue function. Okay. And the only thing you can change is your budget. Your budget. You can change your budget, that is B or B star, whatever you want to give it. No, simply B. Then what is R is the function of B, correct? R is the function of B. If we change the budget, we can change the revenue. Then if we for example, if we can express it, for example, with respect to lambda, okay, with respect to lambda, if we express it with respect to lambda, then how we will write it? We will write it lambda times B, lambda times B, lambda times budget. Okay. Then what is it? The Lagrange multiplier. Lambda times B gives the derivation, derivation of R, that is like this. Right. Derivation of R, derivation of R in what case? For example, dr by dB with respect to B, we are doing it. So that will be lambda times B. Lambda times b will tell us, what does this lambda times b tell us? This lambda times b, lambda times b will tell us the rate of change of the revenue as you move your budget from one point to another point. Okay, the lambda times b, it is lambda times b, for example here, lambda times b. What will it tell us? What will it tell us? For example, if I make it a graphical representation for you for the better understanding, okay, if I make it a graphical representation, a very good, this, please excuse me for this if it goes here and there, because it is, I told you, it is online, no, so not easy to locate the lines. Very good. It's better. Mhm. I will try it with the hand. Let's scale it. Correct. This is our this is our function. So we have revenue function, we have constant function, budget constant function. Correct. For example, revenue function, we will make the budget constant function like this. No, no, not budget, revenue function. This is our revenue function. Okay. And here I will make the budget constant function. Difficult to do. Try it again. Wait, wait. Treat it as it has tangent here. Okay. It's meeting, the meeting point is here. I will make it like this. So this is our revenue function. The top function is our revenue function. Which is the revenue function? This is our revenue function, where revenue equals to 200 h1 by 2 by 3 and s1 by 3. And this is our budget constant function. But what is our budget constant function? 20h plus 170 s equals to b. This is our budget constant function. Then remember what b will tell us. It will give us different combinations. Okay, I will draw two lines here. One is I will draw two lines here. One is this, and for example, one is this. In these two lines, I will show you, for example, it has a, this is our revenue function. Okay. And this is our budget function. For example, this is from 20 to 60,000. Correct? And revenue is our, this is a revenue function, and this is our budget function. This is B. This is, for example, 15,000 to $25,000. It is 60,000. 20,000. Correct? This much you remember. This is budget function. This is revenue function. So revenue is like we want to maximize. Or star means maximum revenue. So what do I want to highlight here is with the change in B from any point, from this point towards here or towards here, it will tell us the rate of change in the budget from if we change B from here to here. For example, it will tell us how much revenue will change, whether it will change this much, this much, this much, this much, or this much. Okay, by giving the different combinations of budget, it will tell us the different combinations of revenue. And same is the case if we decrease the budget here and here, it will tell us different combinations of revenue, maximum revenue, at which point we can maximize the revenue by changing so it is the switch for the revenue. Budget is the switch for the revenue. If we change the budget from one point to another, the revenue will change with according to that. But lambda will tell us the rate of change in the revenue with respect to budget. That is the work of the lambda, and that is the thing I want to highlight. If you understand this, then I will stop. Really, I will stop my class here because there is no need to drag it too much. This is that's all about it. If you really understand this concept by graphical representation and by this everything, I don't need to drag it much because that is the core interpretation of this. This is one point, for example, this is another point. That is the core interpretation of it. Okay, so budget is the switch for the revenue. When we change the budget, increase or decrease, the revenue will increase or decrease, and they are having positive relationship. Okay, budget and revenue are having positive relationship like this. Means, for example, we put a revenue and we will put budget here. If we increase the budget from here to here, here to here, here to here, the revenue will also change. Okay, revenue will also change. So budget and revenue are having positive, but this slope, the slope of this curve, the slope of this curve will be defined by the lambda. That's all about lambda. The slope of this curve will be defined by lambda, means the rate of change in the revenue will be defined by the lambda. How much if we change the budget by from 10,000 to 15,000, at what rate the revenue will change. Correct? Did I make any mistake? I guess no. I will repeat it. If we change the budget from 10,000 to 15,000, or from 15,000 to 20,000, or from 20,000 to 25,000, if we change the budget by 5,000 rupees, at how much more money we can make with the increased budget? How much more money we can make? That more money means what? That means the maximum revenue, how much maximum revenue we can generate with that increase in the budget, and that will be defined by the lambda. That will be defined by the lambda, and that is the role of lambda in the Lagrangian multiplier. And this slope will be determined. The slope of this curve, for example, the slope of this curve will be determined by the lambda. Okay, the slope of this curve will be determined by the lambda. That slope, what is that slope? That slope will tell us the rate of change. What is the slope? The slope is the rate of change of the function, the rate of change of the two variables. When one variable moves by this much, how much another variable moves. So that is the work of the slope, and that's in our case in the Lagrangian function, that is the work of the lambda. The lambda will tell us the rate of change in slope, the rate of change in budget with respect to in revenue, the rate of change in revenue with respect to change in budget. Correct? So this is the budget function. So this is the constant function. Okay, a constant function, budget cost. So this will give us different combinations of budget